Now let's come and talk about the second operator which is used after convolution. You get a feature map, and on that feature map you do what is known as max pooling, which is the second component which even reduces the number of parameters further. So let's see how this max pooling operations work in the convolutional neural network framework. So again, we have this filter, right? We applied this filter and we got this two different, matrices on the original image. First filter application led to this storage of numbers, and the second filters on the application of the on the image led to this set of values that we have. So now let's see how we can do the max pooling operation on this feature map that we have got after applying the filter 1 and filter 2 on the image through the convolution operator. So what we are doing is convolution is done. Now we are focusing on max pooling as an operation. So what will be typically done is, like, you will have a size of max pooling, and so in this case we have a size 2 by 2. So you can see we are basically overlapping 2 by 2, and we are taking a region of 2 by 2 matrices, and what we are going to do here is from those identification in each of this red rectangle or the yellow square that you see here, we are going to pick and only store the value which has the highest number. So if I take this square, you can see that the highest value in this square, in this region that we have, is 3. -1, -3 and 1 are lower to 3. So this max pooling is essentially taking and finding the region and just storing the maximum value in that region that is going to be there. So if you do this in this region, the maximum value is 3. Similarly, in this region, the maximum value is 0. In this region, the maximum value is 3. In this region, the maximum value is 1. And we keep on, finding those regions on the feature map. So now what we are going to do after max pooling, we are essentially going to store this values, which is the maximum values, in the identified square region, 2 by 2 region that we have. And again, that could be parameters that you can change. You can identify 3 by 3 region, and so on, and that is a parameter that you can set while the learning. But essentially, when you define that parameter, what you are going to do is, in that region you are going to find out what is the maximum value, and you just store those maximum value. Okay. So why we do the pooling? Because pooling is a simple way to reduce the overall parameters in the overall image that we have. And essentially, when we are doing subsampling through pooling, we are not changing the overall object. So here is an example of what might happen when you are doing subsampling or max pooling operation. You might have a bigger image, right? And if you do the sampling and if you do the operation that we have discussed, it will result in the same card, but the size of that card or the size of this image is going to be smaller. So that's the meaning of the max pooling, is basically storing the maximum values, and that leads to a smaller image size or smaller output, which will have lesser number of parameters, and we essentially will capture everything that is there in the original image too. And that's why max pooling operation is also used, which reduces drastically the number of parameters that needs to be trained in the overall network. Okay. Again, subsampling or max pooling in larger image will lead to a smaller image, but qualitatively it will capture everything that you have in the larger image too. Okay. So again, what we will have through the convolution operator and the max pooling operator, we will essentially have the reduced number of overall connections. There will be common shared weight, and the max pooling further reduces the overall parameters that needs to be tuned. So essentially what happens is, through this convolution and max pooling, we come from 6 by 6 images. We store all the important information that is there in the 6 by 6 images through this 2 operation, but that is stored now by a 2 by 2 matrix, right? 2 by 2 image that we have, which essentially is 2 times 2 times 2, so 8 bits of information. So that is now substituted the information that you have in a 6 by 6, which is 36 bits of information that we have, but essentially it captures all the salient aspect and all the important aspect that you have here. So as you can see, it drastically reduces the number of parameters that is used to represent what is here in the image, by doing these two operations. And that's the main motivation behind doing the convolution and max pooling operation, because they captures all the salient aspect of the original image but reduces the overall number of bits that is required to store the same information that you have. Okay, so this essentially results in a new image, but the size of that new image is smaller. Okay. So again, the third component, which is important for us to understand, that is typically there in the convolutional neural network, is this flattening and fully connected. So we do multiple layers of convolution and then max pooling. And when we do multiple that, at the end of the pipeline, which I talked at the beginning, we have this third component, which is the flattened and the fully connected layer. And this is essentially very similar to what you have in deep neural networks. So final output that you have here, that will be flattened. Okay, so we have this 8-bit piece of information. So we can take that and we can flatten that and we can create this vector, right? This vector is essentially the flattened vector that will come out of multiple series of application of convolutions and max pooling operator. And from there, after this, the forward, we are essentially going to be using something very similar in the deep neural networks, that we will also have some layers of hidden layers with number of neurons and so on. And that's the third component. So we can see we are doing a lot of convolution and max pooling and reducing the number of feature size. But with this reduced number of feature size, we still have at the end of this pipeline a fully connected network, which also allows us to use the important and salient properties of a deep neural network that might be there.